The next session is about cost-effective solutions for Beam pipelines in Dataflow. I'm Sharan. I'm working as a technical solution engineer at Google. So coming on to the agenda, as you all know, Dataflow is a managed service offered by Google in order to run your Beams, batch, and streaming pipelines. So I'll be discussing some of the techniques or features offered by Dataflow using which you can help increase the worker efficiency and also optimize your overall cost. So I'll go over some of the challenges what generally the users face when running their Dataflow pipelines and how do we overcome using these features like dynamic thread scaling and write fitting for batch pipelines, and how do we tune horizontal autoscaling for streaming pipelines. So we'll start with batch pipelines. So one of the challenge is underutilization of workers. By default, Dataflow workers run one thread per vCPU. So if you're running your workers with 4-core machine, if your workers are 4-core machine, so per worker you'll have 4 threads, and these are the 4 threads that will be processing your data parallelly. So the analysis showed that worker resources are not fully utilized oftentimes. The reasons are various. One of them is, users may be allocating more memory, or sometimes some of the workers are highly utilized and some of them are not utilized. So underutilized workers ideally lead to inefficient spend. So there are ways how you can tune the number of threads on the worker so that you can increase the worker efficiency. But doing it manually, it's manual turmoil. I mean, you don't want to do that manually and make mistakes. So that introduces me to dynamic thread scaling, a Dataflow feature, where it's an opt-in feature which will help you dynamically optimize the number of threads per worker. So it tries to increase the efficiency of the workers. So when the workers utilization, let's say the memory utilization of a worker is less than 50% and the CPU utilization is less than 65%, so Dataflow will automatically adjust the number of threads from 1 to 2. It's basically doubling it. For the past example of 4-core machine, it is going to run 8 threads per worker. That way, ideally 4, now it's 8. So we have doubled the parallelism of the worker, which will in turn increase the worker efficiency, as well as, we are using lesser workers. It is going to reduce the cost. So while we are running these pipelines, let's say during the runtime of the pipeline, if the memory utilization of the worker goes beyond 70%, so we do not want the workers to run with 2 threads per CPU. So Dataflow will dynamically again downscale the threads to default, which is 1 thread per CPU. So overall, it is going to increase the average number of threads per worker, giving you more processing power at same cost. And this can be enabled by passing Dataflow service options equal to enable dynamic thread scaling. And let's say when the pipeline is running, if at all it encounters an out of memory error, then Dataflow will disable the dynamic thread scaling feature. So this is a screenshot from cloud logging. The logs for dynamic thread scaling feature are available in harness logs. So the first indicator shows me the feature is enabled, and the second one shows the recommended thread count as 1. So during the runtime of your pipeline, it will show you 2 when it auto scales. So moving on to the next challenge, inefficient GPU usage in ML pipelines. So when you're running your ML pipelines, you need GPUs. So while triggering your job, you're going to use an accelerator so that when the Dataflow launches its worker pool, it is going to attach the GPUs to that worker pool. So the picture on the right shows, it has launched a worker pool and GPUs are attached to all the workers. Now in Dataflow, you have stages, or ideally Beam, you have stages. So the batch jobs run in such a way that one stage runs after the other. So in this example, we have 2 stages, stage 1 and stage 2. And let's say only stage 2 requires GPU. And when your stage 1 is running, the GPUs are idle, they are not utilized. So GPUs are expensive, so we don't want to do that. So how can we optimize it? We can use the Dataflow's feature called write fitting, where you can provision customized GPUs for your each stage of the job. So in the below example, let's say this is one of my stage, my P transform, and I'm using Beam's resource hint feature, where I'm passing min RAM as 4 GB and accelerator as GPU type and number of count and any configurations, whatever you want to pass. So now the bottom right, it shows you Dataflow is going to now launch 2 workers The first worker is based on default or whatever worker type that you mentioned on at the pipeline level. And there is one more worker which will use the configuration what we have passed using resource hints. This will have GPUs. So when your stage 1 is running, that will be run on your first worker pool. And when stage 2 is running, which requires GPU access, it runs on second worker pool. And those workers have GPUs attached to that. So similarly, that was for GPUs and underutilization of workers, because the same worker type is used for running all the stages in your pipeline. So let's say again we have two stages here, for example, and the first stage might need 4 GB of memory, and let's say your second stage needs 8 GB of memory. So overall, what you're going to do is you're going to choose a machine type which has at least 8 GB of memory. And when your first stage is running, I mean, half of the resources are not utilized. So again, we are trying to deal with over provisioning of resources. And this can be, overcome by using right fitting again, where you can customize the memory to your pipeline stages or steps. So at the bottom, I can see, Beam Pardu, where we have mentioned min RAM as 30 GB. Now the picture on the right shows we have again two worker pools. The first one is going to process the stage 1, and the second one, let's say it will have a 30 GB machines, so that are going to process your stage 2. So basically we are using workers based on your stages. So these are, using right fitting, it's going to benefit you, avoid over spending or over utilization. Since we have multiple worker pools, now there may be a question, horizontal auto scaling work. So in this case, the pools are going to be scaling independently. So when your first stage is running, so it will auto scale your worker pool on the first stage. And when it moves to the second stage, it is going to downscale your first stage workers, and it is going to upscale your second stage workers. And this is the auto-scaling graph from Dataflow job page. Now we get a drop-down since we have multiple worker pools. So they can monitor the worker pool individually, their auto-scaling events. So moving on to the streaming pipelines. So when you're running a streaming pipeline, oftentimes, you get increase in volume of data. So now you have two ways to deal with it. One, you can aggressively scale the number of workers and try to consume your backlog faster, achieving lower latency. The other way is, I'll scale less aggressively and I'll consume the backlog a little slower, but this is going to cost me higher latency, but it is going to reduce the cost. So how do we do that in order to tune the horizontal auto scaling? One is when you're submitting the job, you're going to specify num workers and max num workers. So max num workers is like you're going to set a maximum so that you do not go beyond those number of workers and do not see any surprise in the cost. And other thing about the aggressive or less aggressive upscaling, now we have a feature in Dataflow where you can tune it using worker utilization hint. So by default, Dataflow sets target CPU utilization of the worker as 80%. So whenever the workers reach 80%, it is going to add more number of workers and scale the number of workers basically. Now you have a way where you can tune the range between 0.1 to 0.9. 0.1 is nothing but 10%, 0.9 is 90%. So if you're setting this value to a lower number, that means we are telling Dataflow, whenever you are reaching that CPU utilization, let's scale to higher number of workers. So this is going to help you, scale the number of workers more aggressively and achieve lower peak latencies. But again, since we are scaling aggressively, it may lead to higher cost. So how do you use it for cost effectiveness? So let's say if your business cases are tolerable to higher latency, then what you can do is you can set this to 0.9, the maximum value, so that Dataflow will wait till it reaches 90% of CPU utilization. And it is going to less aggressively scale the number of workers at a cost of higher latency, but it is going to keep your cost lower. Again, this is specific to business use cases which are tolerable to higher latency, and this can be set using Dataflow service options, worker utilization hint, and followed by more details in the public documentation. Thank you.